Hello guys, welcome to our channel and our video of our playlist called C# for Beginners. Okay, so over the last couple lessons, we've built up a pretty solid understanding of classes, properties, constructors, inheritance of all of it, yes? And classes are great, genuinely. They are the workhorse of C#, but they are not actually the only way to model data, and honestly, they are not always the best way either. Today, we are looking at three alternatives: structs, enums, and records, and each one solves a slightly different problem that a uh, regular class is not always great at. Let's start with structs. So let's say we want to represent something really small and simple, like a point on 2D grid, just x and y coordinate. We could absolutely make this class, sure, okay? Let's try this. Class point class, yes, class and public int x get and set public int y get and set here. Okay, and that works fine, but for something this tiny, just two numbers, really, a class actually carries a bit more overhead than we need. This is exactly the kind of situation a struct is built for. So let's rewrite this as one. Struct, struct, point, public int x get set public int y get set. Yep, and we can do point d1 new points x equals 3 y equals 7. Okay, console dot right line can do like that, and e1 dot x e1 dot y. That's it. Let's run our program. As you can see, 3 and 7. Yep. Look at that. Look at that. Genuinely, syntax-wise, almost identical to a class. Yes, struct and class genuinely almost identical. Same properties, same way of creating one with new. So if it looks so similar, why do we even need a separate keyword for this? Well, this is where it gets interesting, and it's really the whole reason structs exist. They behave completely differently once you actually start using them. Let me show you the real example. You see the difference between class and struct. As we had the point class here, yep. Let's create instance of that point class, a new point class with x equal 1, y equal 1. Yep. And then point class, maybe point class b equals a. And then we're gonna write b dot x equal, maybe we make it 99, and console dot write line a dot x. Where is there? Oh, yes, here. Okay, so let's run this. Oh, oh. Uh, let's run this. As you can see, we are printing x point, but it's saying 99. But actually, we changed only this x point, but a also changed. Okay, this probably looks a little surprising if you are seeing it for the first time. We only changed b dot x, but a dot x changed yet. That's because classes are what we call reference types. When we wrote b equals a here, we didn't actually copy the object. We just made b point to exact same object in memory as a. So changing one changes both, because really underneath they are the same thing with two different names. Now let's do the exact same experiment but with our struct instead. Okay, we're gonna make it struct and maybe point points. Point. Let's run this. 1 and console. Maybe call them P1, P2, P1. Yep. And then we're gonna make it and P1.x, then console.writeLine P2.x. Yep. Yeah. Why there's a problem? Build file fix. B does not exist. Ah, yes. It be P2. Yeah, 1 and 99. See the difference? This time, P1 stays completely untouched. That's because structs are value types. When we wrote P2 equals P1 here, the C# actually copied the entire value P2, a totally independent copy. Changing P2 afterward has zero effect on P1 whatsoever. So when should you actually reach for a struct instead of class? Generally, when you are modeling something small, simple, and where copying it around really makes sense, like coordinates or color made of RGB values or simple date range, for anything bigger, more complex, or where you specifically want shared references, which honestly is most of time, stick with class. Okay. All right, then let's shift to something completely different now, a common problem. Say we are representing the days of week or the states of an order. We could just use plain string, yes, or number of numbers for this. For example, like here, string order status or order status, like ship it, yeah, like that, or another status. But see that I actually just misspelled, yes, here. Oh, you can just actually misspell, yes, here. And C# has absolutely no way of catching that for us. As far as the compilers concerned, that's perfectly valid string. This is exactly the kind of situation where enums shine. So let me show you. Enum order status pending shipped delivered cancelled. Yep. And here order status equal order status dot pending, for example, or shipped. Yep, shipped. And then we can write console.writeLine status. Let's see what it prints. Shipped, yeah. And enum defines a fixed specific set of name options, and that's it. Nothing outside outside that list is allowed. If you try order starts.shipped with a typo now, and your code genuinely won't even compile. The compiler catches the mistake for us immediately. For example, I'm saying that if you do something like that, the compiler shows the error. And instead of it silently slipping through and causing a big white down on the line somewhere if you use with strings or integers. Okay, now here's something worth knowing. Underneath each of these options is actually just a number starting at 0. Let me show what I'm saying. Console.writeLine, we're gonna parse it to int and order status dot pending here, and then let's copy paste here, and then ship it, ship it, ship it, then delivered, and then cancelled here. Let's run this and see output. 0, 1, 2, 3. Yeah, by default C# just numbers them in order starting from 0. Same idea as array indexing, if you remember that from a few lessons back. Yeah, but we are not stuck with that. We can assign our own specific numbers if we need to do that. For example, we can do let's see other example. For example, enum, For example, HTTP stats codes. Yes, we're gonna learn about that when we cover the web development classes, hopefully. Okay, stats would be 200, and then not found. I think if you have some idea about programming, you know the 404. That means not found error, and server error would be 500. Yep, that's it. And we can console.writeline int http stats codes dot okay. Yep, and yeah, and run this here. 200. Yeah. It's generally useful when your enum needs to line up with real external values, like actually HTTP starts code in this case, rather than just an arbitrary internal count starting from 0 or 1 or something else. You can just give whatever you want in a way that you understand very well, okay? Now, remember switch statements from gosh, quite a few lessons back now, yeah? Enums and switches are honestly natural pair, and you'll see them together constantly in real code. Let's return the order status. Yep, here, order status. Uh, and order status, how can we do that? Maybe we can do something like that. We're gonna call it status, and order status dot maybe shipped, yeah, shipped, and switch, we're gonna call switch, and status, put here status, and then put values. Case order status dot pending console dot write line, your order is being processed. Oh, I hate that god. Pro pro yes, processed. Yeah, and then break it. Yep, and then case order status dot shipped console dot writeline shipped, that shipped, and break it. And you can do for all of this order stats values. And of course, remember the switch expression version 2 from from the same lesson, same idea, just more compact. We can do something like that. As you remember, we can do string message, for example, and status of status switch, and there will be status switch, and here order stats dot pending and something like that. We're gonna give some string, and then at least we define some default value, and then it would be some string also, and that's it. You can do this kind of things also using the enum and switch. This combination enum plus switch is honestly everywhere once you start reading the real C# projects. Clean, safe, and the compiler even warns you if you forgot to handle one of the possible cases, which is really nice safety net, okay? Okay, one more concept for today, and this one's actually a bit newer to C# records. And to explain why they are useful, let's go back to something we touched on with classes a couple lessons ago. Remember comparing objects. Uh, Let me show you. Class, person, class, public, string, name, get, set, public, int, age, get, set, here, and person class, person, one equal new person class, name equal Alex, age, equal 20. Oh, person 2, maybe its name is Alex. Yeah, they are same, but just new variables. Yeah, and we can write console dot write line person 1 equal person 2. Yep. So let's see the output here. It's false. Yeah. Wait, false. But they've got the exact same name, the exact same age. They shouldn't they be equal? Well, remember what we learned about classes just a lesson or two ago. They are reference types. Yes. So equals here is not actually comparing the data inside them. It's comparing whether they are literally the same object in memory, and they are not. They are two separate objects that just happen to hold identical values. This is exactly the kind of situation records were built to solve. Let me show you the example for record. Record person, string, name, int, age. Done. And person, it's syntax error. I think person, oh, person, person 1 equal new person, Alex, and 20. Yep. Okay. Okay. And now let's compare them. Let's see the result here. It's true. This time is true because records automatically compare based on their actual values, not just their memory location. And notice to how much shorter this whole definition is: record person string int age, one single line. And we already get properties, a constructor, and this kind of value-based equality all for free. Now here's another neat feature that comes with records. Since the data inside is meant to represent something fixed, records make it really easy to create modified copy of an existing one without disturbing the original one. Let me show that. For example, person 1 and person. For example, birthday person. Yes. And what we're gonna write is here original with age equal 21. Search birthday person original with actually why yeah, yes, it's not original, it's person 1 actually. Yes. Up age. Okay, like that. And console dot write line or person 1 dot age console dot write line birthday person dot age. Let's see that. It's 20 and 21. That with keyword is doing something really elegant here. It says, give me a full copy of original or the person original value per original person, but change this one property, age, along the way. Everything else, name, in this case, just carries or automatically. This pattern is honestly real common once you start working with data that shouldn't be modified directly, only replaced with an updated version, which by the way connects nicely to something we are going to see a lot more of later on when we get to advanced C# patterns. Okay, and let me bring all of the things that we learned today. Today. Okay, so enum, we can start with enum order status. Yeah, maybe pending, shipped, delivered, Okay, and then record order string, maybe product name, and order status. Yep, and then struct coordinates public double latitude public double longitude. Okay, now we're gonna create our order one equal new order of laptop and order status, maybe it's shipped. Yeah, it's shipped, and coordinates, uh maybe warehouse block equal new coordinated, with latitude equals maybe 40 points, longitude equals maybe minus 70.0. Okay, that's our warehouse location, and then we're gonna string status message equal order one dot status switch, just switch, then order stats dot pending processing your order. Order status that ships on its way. On its way. Order stats dot delivered. Delivered. And then default on unknown. Unknown. And here we can write console dot write line. Maybe this one. Order one dot product name and its status message. Yep, and then status message console dot write line shipping from warehouse location dot latitude, comma, warehouse location dot longitude. Oops, longitude. Yep. Okay, and then order updated order equals order one with status equal order status dot delivered console dot write line update order dot status. So let's run this code. Okay, laptop on its way and shipping from this location and delivered. Okay, so let's see the basic structure. There's an enum for fixed set of statuses and record combining that enum with product data and giving us clean equality and easy copying, and a struct handling something small and self-contained like coordinates. Three different tools, each one picked because it actually fits the jobs best. And honestly, learning to recognize which tool fits which situation is a big part of what makes someone a genuinely strong C# developer or any software developer. Okay, so that's all for today's lesson. And then at the end of the video, I'm going to give you a small challenge conventionally. So the challenge is create an enum called membership level with options like bronze, silver, gold. Then create a record called customer that include a name and membership level. Create two customers with the same data and prove to yourself they have equal using they are equal using the equal sign. Then use with keyword to create a new customer upgraded to gold from an existing one. Okay, so today we cover structs how they behave differently from classes because they are value types, not reference types, and arms for representing a fixed safe set of options, and how they pair naturally with switch statements and records, which solve that value equality problem classes have, while also giving us that really elegant give syntax for creating modified copies. Yes, next time we are moving into exception handling, how to deal with things going wrong in our program gracefully instead of just crashing. See you there. Take care.